All right, we're going to do a deal with circles again. I had a whole chapter on them. But this is a little different than what we did with the circles. But there are some similarities also of what we did with the other circles. If you remember, we did a lot of stuff with circles in that chapter. I forget what chapter it was. Chapter 10 or something like that. I guess it was the last chapter, yeah. So one of the things we did was we found the perimeter of the circle, but we gave it a special name, didn't we? What was that special name? The circumference, right. We found the circumference of the circle. Do you remember what the equation for circumference of a circle is, or the formula? It's 2 pi r, right. Or another way you could say it, you could say what? Pi times the diameter. Okay, either way, this means the same thing, because twice the radius is the diameter. It's the same thing. But 2 pi r is kind of like the familiar way to say it. A lot of students get confused between the two formulas. Not these two formulas, but the one I'm going to give you next. This was circumference. So what are we doing when we find this circle? We're finding the what? The distance around the circle, okay? So if this was a piece of string and we cut the string and we stretched it out and we measured it, we'd find out how long that piece of string was. That's what the circumference is. Remember doing that, don't you? Okay. What we're going to do now, though, is we're not going to find the circumference. What's this chapter all about? It's area, right. So we're going to find the area of the circle. Now, what does that mean? That means if we were to split it up, I'm not going to do this, but if we were to split it up into as perfect squares as we possibly could, how many squares are going to be in this circle? I don't know. Might as well try it. Let's give it a shot. Okay. So let's kind of do this. And then, I don't know, we'll go this way too. I've never actually tried this before, but let's see. Maybe go halfway might be good. Now, I'm not going to be able to do this perfectly, but we'll get the idea. This is not really a proof or anything, but this is kind of what you're finding. If I was to take this and split it up, it's probably off a little bit, isn't it? I don't know if this is going to work out too great, but we'll see. Probably scooch that over a little bit more. I'm just trying to get them to be about the same distance apart. And then, what would we do? Take it this way. Try to... Oh, that's way off. Try to split that in half. I don't know. You get the idea, don't you? That's pretty close. About right there. About right here. Oh, that's off a little bit. You get the basic idea of this. But look at this. You've got a bunch of squares in here. Pretend they're all perfect squares, okay? So look, you've got a square right here, you've got one here, you've got one here, here, and you got them all over the place. But you also have some figures that are like this. That's not a perfect square, is it? So we can't just sit here and count up all the squares like we did on that rectangle. Remember the first thing we did? We talked about finding the area. We took that rectangle, we broke it up into all these perfect squares. We could just count them up, right? Count across the rows and the columns, and you can find out how many squares you have. On this one, it's not quite as easy because look, this is not a perfect square. It's got a curved part to it. So that's kind of weird. But it's basically what we're doing. How many squares are we going to have in this circle? If I was to count them up, 1, 2, 3, 4, 5, 6, 7, 8, count them all up, I want to find out how many squares are in this circle. But that's going to be really, really difficult to do because that means I'd have to combine this one with this one. Does that make one full square? Does it make 2 squares? Does it make 1.37 squares? Whatever, you know? That's what we got to figure out, and that's kind of hard to do. But we have an equation that helps us out here, our formula. And what it is, we still deal with pi because we deal with pi a lot when we deal with circles. But it's going to be pi, and it's going to be r. Looks very familiar to this, doesn't it? But do you remember the rest of this? Squared, pi r squared. So you're only squaring the radius. Okay, you're not squaring the pi. Some people get confused on that. But you're only squaring the radius. So it's pi times the radius squared. Again, in the book, they give you a little I don't know if you'd call it an example, but they give you a way to figure out how they came up with this formula. All right, it's kind of interesting. I'm just not going to take any more time. I've already taken enough time with this dumb thing. But that's basically what we're doing. When we find the area of a circle, we're trying to find out how many squares can you fit inside this circle. Most of the time, it's probably not going to come out to a nice even number, wouldn't you think? Because look, there's a little bit of it. See how this one has a curve, so you know it's not going to be a nice perfect square. So it's probably going to come out to a decimal. Every once in a while, I guess it could come out to Well, not really, because if I take a number and multiply it by pi, I'm always going to get some kind of decimal. You might get it to round to 0.0, but it's still going to be some decimal. All right, so it's not going to be, you're not going to get a perfect number of squares that fill up that circle because of pi. Because pi is 3.14, 159, blah, 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 blah. Right? And it goes on forever. It's never comes out to a nice perfect whole number. Does that make sense? All right, enough of that. That's all you got to remember, that area is pi r squared. That's the thing that I want you to remember here. It's not that difficult at all. So, watch. I'm not even going to draw a circle. I'm just going to give you the radius. What if the radius was 3, and the question is, find the area of that circle. We'll call it 3 inches. What if the radius of that circle is 3, and I want to find the area of the circle? Well, what do? We put it into our little formula, pi r squared. So I've got pi, and then I take the radius, which they give me right here, which is 3, and I square it. So what is that? That's 9 pi. Now, I used to have a book that they were perfectly fine with you keeping it just 9 pi. All right, but I think this book always takes it and puts it into a calculator. All right, so it's 9 pi. To tell you the truth, if you kept it 9 pi, I'd probably, on a test or quiz, I might give it to you. All right, I probably would give it to you. Unless I say round it to a certain number of decimal places. If I say round your answers to 2 decimal places or to the nearest tenth or something like that, then I would not accept this. All right. So you just have to read the instructions. It's kind of nice if you could keep it like that because I don't have to worry about pulling out the calculator and plugging stuff in. But on this one, I would just hit 9 pi, and pi is this button right there. So there it is, 9 pi. Now on your calculator, if you have a TI-30, you don't just put a 9 next to a pi. You would put 9 times then the pi button. All right, and then you get 28.27. Let's round it to the nearest tenth, so that would be 28.3. So that would be 28.3. What did we just find? It's 28.3 what? Inches squared, right? What did we just find though? What does that mean? It means the area, but describe that. That's right. You could have 28.3 squares inside of that circle. Okay. The 0.3. Why the 0.3? Why do we just have a fraction of a square? Because we've got those curves all around those outside squares, don't we? All right. So it's not going to come out nice and perfectly even because of pi. Pi doesn't come out perfectly even, so our answers are not going to. Make sense? All right. Well, if they give you the radius, that's about as easy as it gets right there. Okay, they could give you the diameter of the circle. That's supposed to be a D. I'm making that even worse. Let's try it again. There we go. Let's say the diameter of the circle was 17. That would be, diameter times pi would be what? Is it? Is that? Oh yeah, you said it. That would be the circumference. I'm not trying to find the circumference. What am I trying to find? The area, which is pi r squared. So what do? Take half of this. We got to find the radius, right? So I would just put 17 over 2. Or Chandler said, what is this? 8.5. Okay. If you want to do that in the calculator, whatever you want to do. Okay. So you got to find the radius first, because make sure that you understand what they give you. Sometimes they'll give you pictures and they'll mark it on the picture what's given to you. Sometimes it'll just be like a sentence, and they'll say, okay, if you have a circle with a diameter of 17, find the area. And you just have to be able to do it as well. That's not so hard though, is it? Take the diameter, change it to radius. Now you could plug it in, so it's pi times 8.5 squared. Throw that into a calculator, and let's see, we got 8.5 squared times pi. What's the pi? That one right there, and then there it is, 226.98. But what does this do? This 8 rounds this to a 10, which means you carry the one here, so it'd be 227.0, wouldn't it? Well, if I said round it to the nearest tenth, if you just put 227, that's not rounded to the nearest tenth, is it? How do I know it's not 227.4 or 227.1 or 2 or 3, or right? You with me on that? This right here tells me that this is a significant digit, okay? Did you learn that in 9th grade science? Anybody take it? Who's in 9th grade in here? A bunch of 9th graders, right? Did you learn significant digits in science class? No. You didn't? I bet you did. You're probably sleeping during that part of it. You never heard of significant digits? Well, if you take physics or chemistry or something like that, then you'd probably learn about that. But if it says round to the nearest tenth, you have to have a tenth place, even if it's 0. Because this tells me that it rounded to 0.0. Does that make any sense? You guys are looking at me like you're stunned. All right. I understand. But this is rounded to the nearest 10th place. Yeah, if it says round it to the nearest 10th and you don't have the point 0, absolutely. Because just 227 doesn't tell you how accurate this is. This could have been 226.5, couldn't it? 220. But you're saying it's the same number. But this flies in the face of what you're telling me. You're saying, well, 227 is the same thing as 227.0. But if this was 226.5, 226.5 is not the same as 227, is it? Even though it rounds to 227. All right, I'm not breaking through, and I don't care because I'm not going to be super picky about this. But if they say round it to the nearest 10th, you need to have a 10th place there. Don't just write 227. That's not rounded to the nearest 10th. This is rounded to the nearest 10th because you have a 10th place right there. Rachel? Are you that cold? Go ahead. I thought we'd get some fresh air in here. Everybody would enjoy it. All right, so just take my word for it, okay? Wait till you get to chemistry or physics or one of those classes, and they'll explain it in more detail about how important that decimal place is. All right, let's keep going. What else could they give you? They could give you the area. All right. I don't know. I'm just making something up. Let's say 67. All right, for whatever reason. Let's say they give you the area is 67, and what do you think they ask for? They could ask for the radius. All right. So how would I find the radius if they give me the area of 67? So what's the formula? It's pi r squared. What do they give me this time? They give me the area. They don't ask for the area, they give it to me, and they ask for the radius. So it's equal to what? Pi times r squared. So how do I solve for the radius? What's the first thing I do? Divide by pi. That's right. So get rid of the pi, so I divide by pi, and then what do I do to get radius by itself? Square root it, right. So square rooting this will get rid of the little 2 up here, the squared, and that means I have to square root this. All right, so that's what I would put into my calculator right there. So let's do that. So do 67 divided by pi first. Okay, and then take the square root of that. So take the square root of the answer. And there it is. It's about 4.6, okay? So if I ask you to round it to the nearest 10th, 4.6. And that's what the radius would be. Okay? Let's say they gave that to you in centimeters squared. What would my answer? What would it'd be just be centimeters. It's radius, okay? It'd be just in centimeters. We good with that? All right, let's do something else. A little bit more challenging. But it's something, oh man, that shouldn't be a reaction. It should be oh yeah, not oh man. And it shouldn't be a sarcastic oh yeah. Yeah, I still hear sarcasm in that. All right, look at this. Oops. Watch. What if we've seen this before? Okay. Do you remember what we did on this? We found the length of that arc right there. Okay, and what did we do? For instance, if we were doing circumference and I told you the radius was, I don't know, make it easy, just say 3. What if the radius is 3 and I wanted to find the distance, and we need to know an angle also, don't we? Let's say it's, I don't know, 35 degrees. All right, so this angle is 35 degrees, the radius is 3. We did this before when we did the circle chapter. We found the length of this arc. We'll call it arc AB. Is that all right? We'll call this C. So if I wanted to find the length of arc AB. Now this is old stuff, okay, this is not new. I'm just showing you how this relates to what we're going to do today. What'd you do for this?
365.
365?
Or 360 divided by 35.
You sure about that?
No, it's the length of the arc.
Look, it says 35 degrees out of what? 360. Out of means to divide by. So it's 35 degrees out of 360. So we're not doing all 360 degrees, are we? We're just doing a little bit of it. 35 out of 360. Does that make sense? Minus? Why are we minusing? Right. It's this fraction. It's 35 out of 360 of the whole circle, right? So what would be the circumference of the whole circle be? It'd be 2 pi r. right? That would be the whole entire circle. But we're not finding the distance around the whole entire circle. We're only finding the distance around this part of the circle. I thought this would be review. It seems like we're dumbfounded on this. I don't know. Does that make any sense? We're not finding the circumference of the whole circle. We're just finding the circumference of this bit right here. This is only 35 degrees of the whole circle, right? That's the fraction of the whole circle that we're trying to find. So that's why we write 35 over 360 times 2 pi r. Does that make any sense at all? Okay. So we were supposed to have already known how to do that. I thought that would just be review. It seems like I'm teaching that for the first time. Area would be the same basic thing. What if I wanted to find the area of this whole chunk of the circle? But we don't call it a chunk of the circle. We give it a better geometry name. We call it the sector of the circle. Okay? Now, the sector is found when you take the radius, 2 radii, right? And the radius always has to connect to the center, doesn't it? Right? So you can't just have like this and this. We're not doing that, okay? At least not now, anyway. All right, so we're just doing this. It goes to the center, so they're both radii. This is 35 degrees, but now we're finding the area. Okay, we want to find the area of the sector of the circle. So I'm not finding the area of the whole circle. The area of the whole circle would be pi r squared. How much of the circle am I trying to find? Just 35 out of 360 pi r squared. You get it? This right here would be the whole circle. I'm not trying to find the whole circle. I'm just finding this chunk of the circle, this piece of the circle. So how much of the circle am I trying to find? 35 degrees out of 360 degrees of the whole circle. Of means times, so this is this times pi r squared. So let's put the actual number in here now. 35 over 360 pi r, which in this case is 3, and we square it. So that's all the stuff that we put into the calculator. Alright, let's put it over here. So let's stick it in the calculator, see how to do this. So it's 35 over 360. I'm not going to put times. Actually, you know what I'm going to do right here? I don't know if it'll fit this in here or not. Nah, I figured it didn't. Let's just put this in parentheses. 35 divided by 360 again. Because if I just hit times, it probably would take that 360 and multiply it by something. I don't want to multiply 360. I want to multiply that fraction by something. So it's 35 over 360 in parentheses times pi. So in this calculator, I can just put a pi right here. Now I got to put times 3 squared. I can do that in my head. What's 3 squared? 9. Okay. Punch that in there, and there you go. So that right there would be the area of that circle. Okay. So 2.7. Yeah, let's say, no, it wouldn't be 2.8, it'd just be 2.7. You only look to the right. This 4, you only look here. You don't keep looking over here. All right, or we'd go on forever, wouldn't we? So you just, it's 2.7. 4 does not round the 7 up, so it's just 2.7. So, so the area would be 2.7. Whatever the units are, units, we'll put units squared, because we are finding area, aren't we? Now, that's not the area of the whole entire circle, is it? 35 out of the 360. And it doesn't mean 35%, does it? Just for fun, let's figure out what 35 over 360 is. It's 0.09. It's about, let's say it's about 10%, right? It's close to 10% of this whole circle, because 36 degrees would be 10%, wouldn't it? 35 is pretty close, just a little less than 10% of the whole circle. Make sense? All right. So that's basically what you do. I don't think it gets much more difficult than that at all. Yep. Yeah, I think that's good. So let's give you some problems to do. Why do you react that way? We do that every time.
You say, oh yeah.
Actually, you don't even have to say anything. I mean, you know I'm going to give you homework. Haven't I done that all year long? This is for your own good. Don't you hate when your parents tell you that? This is for your own good. Right before they spank you, or right before they give you some medicine or something like that, and you think it's gross and you think it's the worst thing ever, but it really helped you in the long run. That's what this does. Just wait. There you go. That's what you're doing. You got about 10 minutes to start it, okay? So you should get a good chunk of those done in the next 10 minutes if you start it right away. If you start it right away, you got 10 minutes to work on this, and then do the rest at home. All right, have fun with that.